Today we will talk about lambdas, serverless, and serverless. That's what is today everything. If you run any applications, if you are building any applications, if you are building anything in cloud, it should be serverless because you pay per processing power or per processing time. So any new modern applications are being serverless because it allows startups and new companies, which needs to be really fast, to develop faster because you take care only about your code. Anything else, it's not your business. So you don't need any servers, you don't need anything, only your code and provided runtime environment. If we will talk about lambdas, you will really need to know that there are some alternatives in GCP or Azure. In Azure, they are named Azure Functions. In GCP, they are named, not so very inventive, Google Functions. So we're talking about the functions. These functions are not necessarily the applications, but they can be also something that will be event, and it will happen. This event will appear in your small cloud box and it will do something for you. For example, it will tag your instances or it will disable specific instance in specific time because you don't want to pay for that. And that's a very valid case. So functions or Google Functions or Azure Functions or Lambdas will allow you to react on specific events and build event-driven architecture. And that's amazing because if I remember the old days of on-prem, this was not possible. These things were not possible because you didn't have this power to spin some code, execute it, and then just forget that it was there. And that's what we'll talk about today. And we're talking about also the security. Security is something that companies absolutely forget to solve because they live in the idea of AWS will solve this for me. They take care of all the security. And that's not true because you are responsible for taking care of security of your code. In Lambda's case, code is everything in that case. You need to run your code reviews, you need to do lots of things, not just code review, but open source security scanning, dependency scanning. So all of these activities that you will normally do with your software. So what is AWS Lambda? AWS Lambda is event-driven serverless compute service. As I already told you, with a custom logic, and it can create backend services if you need it. It operates in the scale, so you can spin up as many lambdas you want. It's parallel computing processing power, and you can define how much resources you will allocate to that. That means CPU and memory that it will be consumed, and you just pay for processing time. So it's up to you to optimize your code to run as fast as possible, and it also allows us as ethical hackers to attack the right places because timing attacks are very critical for lambdas. If I, as an attacker, can, push your lambda to run longer than it needs, I will force you to pay more. And if I will be able to cycle your lambda, imagine the bill. That will be really epic. So lambda can run the code in response to specific events or HTTP requests. Depends what is the invoke mode of that. And you can also use Lambda with combination of API gateway. So I remember the old days of enterprise service buses. I hope that you are not having that in your company. If yes, I wish you best luck. So AWS API gateway is basically the entry gateway to your AWS environment. And you can use Lambdas basically as like REST calls or REST responses. And every REST call or a REST microservice, if you will call it like that, can be something that will be invoked through the API gateway. Or you can modify the S3 buckets, you can put something in the S3 bucket, you can delete something from S3 bucket, you can modify your DynamoDB data, which are NoSQL data, and you can create something what is very cool. It's called step functions. Imagine that you have a decision tree machine, which is executing lambdas in different order based on the output of previous computing. So that means, what it means? And that means that you can have 3 of the functions And these functions will be executed. These functions will run in specific order. There can be parallel computing. There can be like sequential computing. So lots of interesting things can be done with step functions. And for me as a security guy, you can have really cool playbooks that will do lots of things for you. Key benefits: no service. You pay per processing time. AWS is so good that they can measure, or their metric system can measure 1 millisecond. So Lambda manage scaling for your functions. That's also very good. And they are isolated. That means that they run in the isolated environments. They do not share any storage if you do not implement that. And there is also AWS Serverless Application Repository, which is a managed repository of serverless applications available for everyone. So what you can do, you can go to AWS Serverless Application Repository. This repository allows you to get access to serverless applications available, ready to use out of the box. You don't need to code anything by yourself, and it's pretty good for beginners who really don't understand how Lambda works, or if you're looking for specific purpose Lambda, you don't need to write it from the scratch, which is pretty cool. That's something that helps you a lot, and I recommend you to go there, check it, and maybe you will find something that's beneficial for your purposes. It's also that telling you that each application is packed with AWS Serverless Application Model, which is a template which defines AWS resources in the serverless way. So you can go click on Browse All Applications, and then you will get to more than 615 applications ready to create custom IAM roles or resource policies or tagging lambdas or whatever. So if you are interested in a specific lambda, you can write tag, and for example, I'll filter this one, and it will give you all the applications related somehow to tagging. So EBS tagging lambda, tag EKS cluster lambda, tag EKS cluster lambda, different one, and AWS tag explorer. So these things are pretty beneficial for everything that you really want to try in AWS, play with that, enjoy the real cloud engineering. What is interesting for us as a security engineers is vulnerable applications, and there should be some of them. Okay, I will write vulnerable, and in that case, you see that there are already 5 serverless applications vulnerable by default for your usage, and you can play with them. You can enjoy by trying breaking serverless applications, and that's really amazing today because you don't need to spin any server. You don't need to have heavy local host build system with the web and everything around that. You don't need to spend hours on debugging why it doesn't work. You just run it, and it will appear as lambdas, and you can play with that. You can test your OWASP top 10, OWASP serverless top 10, and here is serverless Go, serverless Java Go. So you can try and play. That's what I can recommend for you. Lambda layers can be used to share specific code or library with other lambdas in your account or another accounts, which is really cool because if you have shared code and you want to reuse it multiple times, Lambda layer is the best case for you. Few facts. AWS Lambda uses TLS 1.2 plus. So that means that it can also use TLS 1.3. So security of SSL layer is very important for AWS, and AWS team, which is managing Lambda, they use something called AWS Inspector. You can imagine that as vulnerability scanner. And this vulnerability scanner called AWS Inspector is used for the instance security. I mean instance security on the host system where Lambda is running. It is using Firecracker. So they scan for operating system vulnerabilities with AWS Inspector. Environment is patched by AWS. So you don't need to care about that. And if you want to use some storage, there is something called TMP, so temporal storage, that's backed by AWS EC2 instance store, and it's encrypted at rest. Very interesting. So you have some ephemeral storage that you can use. And Lambda can be backed, if you want, with EFS, which is Elastic File System. You can think about that like NFS. So if you are used for network file system, and EFS is basically network file system, then you can use it too, if you want. And then the architecture of whole solution is pretty epic. Imagine that you have bare metal for EC2, then the Firecracker micro VM. Firecracker, it's a virtualization technology from AWS. It's open source, and its main purpose is to serve for Lambda or AWS Fargate. This is very lightweight virtual machine solution which manages something called micro VMs, and it's also based on virtual machine monitor, and it uses a Linux kernel virtual machine called KVM. I think that you have heard about that. And if you will look at the Firecracker webpage, you will find lots of interesting information, how it works, how it is built, how it works with the operating system, how the segmentation namespaces are built. It works with the bare metal, so that's obvious because behind clouds there is always some bare metal. And there are lots of FAQ questions, lots of things that if you want to learn about that. There is also reference to Jeff Barr blog. So you are free to go with that. And because it's open source, you can basically experiment with that. These Firecrackers, micro VMs, they can separate the different Lambda. So you have different customers. They are running in Lambda sandbox. And this execution environment, if you will take it like that, are having separated function codes. They have separated ephemeral storages. And also the layer code is separated from each other. If you will look in which system it is baked, so you will see that it's using Firecracker micro VM. So here is one Firecracker micro VM, and here's second Firecracker micro VM. And all of this encapsulates the customer environment, customer code, and the runtime for language that you are selecting to run your code. So only problem that you should have when you are running any serverless application is selecting the right version of your runtime where you need to run your Python, Node.js, whenever code you like. So how the isolation works. So to disclose how the isolation works, you need to understand that this is Linux. Lambda equals Linux. Very simple thing. It uses C groups, which is used for constraining the code access to CPU and memory that you define that it will use. You are using namespaces, Kubernetes. Did you hear that? Namespaces. So namespaces are the basic tool, or I will say maybe mechanism for separating different environments in the containers are used here too. So then second BPF, like Barclay's packet filter for network traffic analysis. That's a very known system for analyzing any traffic. IP tables and routing tables, which are telling you what ingress is allowed. So basically it helps you to prevent network communications and isolating network connections. Then KRoot, provide the scope access to the underlying file system. And then the Firecracker itself. Firecracker configuration, which helps to block the device and network throughput. Firecracker is just a container service or containment service, lightweight container service, virtualization service from AWS. So invoke modes, that's something also very interesting. AWS Lambda can invoke an API in two different modes. One is event mode, and second is request response mode. This event mode queues the payload for an asynchronous invocation. And the request response basically is synchronously invoking function based on the provided payload, and it returns the response immediately. So it's like event-based architecture. When you need to have event-based architecture, you go with event mode. And with request response is basically for applications like HTTP HTTP-based applications or web applications, that's the best way where you can use it. For event mode, you can have like scheduled Lambda that it will be due like a daily tagging or daily cleanup on some instances. So pretty cool stuff too. Lambda observability. If you will think about Lambda observability, that's something that is very important. How you will monitor it, how you will log it. So think about X-Ray, which is like a native observation platform for tracing the Lambda calls, how long they last, what is the return code. So lots of interesting insights that you can get from X-Ray. And AWS config will help you with compliance and knowing if your Lambda is configured well. If you will talk about CloudWatch and CloudTrail, these two services will be really good in CloudWatch for logging and CloudTrail knowing who is doing what. So if you want to have like secure environment and you want to know who invoked Lambda or which service calls Lambda, that's the best place where to get it is CloudTrail. So OSS scanning for Lambda. That's something what I think nobody does perfectly or maybe don't do at all. Dependency scanning is super important. Plus, super important. You need to do because last year attacks on supply chains showed that dependency scanning is super important to know which libraries are you using, what is their security, if there are some vulnerabilities, if they are misused, all of these things. And continuous open source security scanning is super important to get your Lambda in good shape. Also, you need to know which dependencies are you pulling, for example, to Lambda layers. And for that, you can use Prisma, Snyk, Whitesource. Snyk is pretty good because it's easy to implement. You are just implementing your cross-account role to the Snyk account, and they will provide you information about your OSS posture or OSS security level. First step that you will do when you want to run open source security scanning or dependency scanning is define the role for Snyk. In our case, we'll talk about Snyk, which is pretty cool platform for open source scanning, infrastructure as a code scanning, Kubernetes scanning. In that case, or in this particular case, we will focus on Lambda scanning. So let's go to AWS, and from AWS, you need to go to IAM, Identity and Access Management. Create a new policy, and this new policy will be the policy for Snyk to be able to get our Lambdas. So I will say JSON. I will replace that with prepare JSON, which it will allow us to list the functions, get functions, list aliases, and get account settings. So I'll click next. Okay. Visual editor, visual editor looks okay. Yes, Lambda, fine, good, looks okay. So let's go to next. I will skip the tags and I will name it Snyk Lambda policy. And this Snyk Lambda policy will help us to be helpful in the role that we'll use for getting access to our resources and doing some scanning. So click on create policy, and when you will create this policy, which will allow us to get an access to Lambdas, you need to create a new role. So you will click on roles, create new role, which is second step, and you will say another AWS account. And another AWS account is a unique ID of the Snyk account. So then I will click on, then you need to require external ID. In your external ID, you will select your ID and then next to permissions. The ID is your organizational ID in Snyk, which is pretty easy to get there. And then you will select the Snyk policy. So I have multiple of them because I was a little bit messing with that. So I will say this is my Snyk policy, then I will click next tags and then review, and it will create, and then I can name the role whenever I like and then create the role. But because I already have one, so I will not complete the creation of the role. That's the first actually package of the steps that you need to do before you will scan your Lambdas. For today's demo, I'll prepare for you this AppSec serverless code, which is by default vulnerable serverless function. So you can try it too. It's in a serverless repository from AWS, so you can spin it up and play with that. So these functions, if I will say, if we'll look to Lambda functions, you will see two new functions created by this serverless application model. And when we will go to Sneak, the integration looks in the following way. So you will go to serverless and then you can configure your Lambda. So then you need to put there the AWS resource number of the role that we created together. When the role is created, then basically you will add it, you will save it, and you can have as many roles you want from different accounts. It will attach the specific account to your Sneak account. So pretty simple. And what we can do, we can go to the projects. And in the projects, so you already see that I already have some Lambdas there. I can say add the project, click on Lambda. And in Lambda, I can select which Lambdas I want to include. So for example, I can say I want to have whole EU West region, but I'm not interested in that. I'm specifically interested in these two Lambdas. These are like some random Lambdas that I created before. And I will select latest versions of these Lambdas will be scanned. So I will click on add two selected functions to Sneak. So then it will add these functions. It will run open source security dependency scanning. And that's pretty simple. And after that, it will tell me what are the vulnerabilities in this specific Lambda functions. This is pretty cool. And not like in the code itself, it will not do the code review, but it will check the dependencies and third-party libraries. So it is doing third-party library scanning for you. If we will, I will clean this up for you a bit, and we can go to, for example, this one, because this looks pretty vulnerable. And I will go to this file, which it created, POM file, that I will be able to check from the perspective of severity, priority score, if it is fixable, exploit maturity, which is pretty cool too, to know if there is an exploit that hackers can use or not. And in that case, we have around 50 different vulnerabilities. In these 50 issues, you will see that there are lots of problems with deserialization of unstructured data. So insecure deserialization is one of the problems that occur in my Lambda. And it will also tell you some detailed paths that where it is, what it is, what's affected, and it will give you some overview where the problem is, which library is vulnerable, and why you can ignore the specific case. And you can say this is not vulnerable, or ignore it temporarily, or ignore permanently. That means forever. And you can also select amount of days when you will ignore the specific finding. And you see also score. And if we'll go lower and lower, we can find another vulnerabilities. For example, problems with HTTP client, problems with common codecs, or improper certificate verification, which is also a problem for lots of applications, or denial of service. So yes, there is an applicational denial of service, and you see here, again, the detail of the problem. It's pretty simple, and the integration is pretty neat. So if you want to check it, if you want to see the dependencies, it will give you the list of the dependencies. It will build a dependency tree for you. Another very cool and important service is AWS Code Signer. Code signing is about the integrity of the code. So if nobody who shouldn't do that modified your code or did some unintentional changes in your code. So AWS Signer is fully managed code signing service to ensure the trust and integrity of your code. Code signing for Lambda is available out of the box, and you can also use it for IoT signing, which is pretty cool too. And you can use Signer to create digital sign packages for your Lambda deployment. So with Signer CLI, with SAM CLI, which is Serverless Application Model, or with the AWS SDK. CloudTrail helps you always track who created the signature. Another really good usage of observability in AWS. So the integration is obviously with AWS Certificate Manager, which helps you to provide the certificates for your signatures. Cross-account signing, that's a very interesting feature available for us in AWS. Imagine that you have publishing and consuming account. You have zip file with your application. Signer will sign with the digital signature or zip. You will publish that in Lambda. And this Lambda layer can be shared with other consuming accounts. These consuming accounts needs to have permissions to consume the Lambda. And basically, in a very simple way, these consuming accounts, they can have their own Lambdas, which will be signed, but they can also use signed layers from publishing accounts. So this is very cool stuff where you can have publishing account for shared resources and consuming account where you have your own Lambda signed without any problems. So let's play a little bit with AWS Signer, which is a signing service for your artifacts. It's pretty cool, pretty neat, and again, lots of fun to get this. It's I guarantee you this. That's easy to use like nothing else, you know. So let's go. I think that you have more problems with your own kits. So let's go to AWS Signer. I already have some Revoke profiles, so I will say my profile. So let's do it like this, and I will say okay, from 1 day to 135 months, I will have something like 25 days, so maximum is 11 years, that's it. And then you can add some tags, so environment will be production, and this will create a signing profile for me. That means how long the signature will be valid. So I'll create a profile is running, it's working. So then I can start a signing job. So that's where the magic really happens, because that's where you will assign a specific artifact in your S3 bucket and then store the signature in another S3 bucket that you want. So I will say browse S3, and for example, in this one, I have application called Bookstore. I will select this one. It's basically Java application, and signature destination. So here you need to specify an S3 bucket path for uploading the signature. And the prefix will be appended to the job signing job ID. So, okay, I will browse, and for example, I'll say, okay, in the same bucket, please store for me the signature itself. So I will say, okay, here, and don't forget to select object version. If you have enabled bucket versioning, you really need to select the specific version of your object. So start a job, then pretty fast. You see here that there are some failed jobs, some succeeded jobs. And when I will go to job ID like this, it will tell me what's the job ID and signature destination bucket. What is the code asset, source key, and the signature destination key. So I will go to signature destination key, and it will redirect me to exact bucket with the signature itself. And let's go to Lambda. If you want to sign in Lambdas, basically here, if you store the code somewhere, so in the configuration, if you have Lambda signing profile ready, you will say edit code signing, and then I don't have configured any profile for this unvalidated code, but this is where you will edit the code signing. It's pretty simple. So I think that everyone can do that, and I hope that you will try it at home. So that's the end of this demo, and not the end of today's session. Then performing code review on Lambda is super important in the same way as you need to do code reviews on your applications. And I'm not talking about the peer review and code review. Everyone should do that. I'm talking about SAST, security application testing, or static testing, static review of your application with automated tools. Lambda is like any other application. You need to think about Serverless top 10. Serverless top 10 is a document from OWASP that is mapping OWASP top 10 to top 10 vulnerabilities that are located in the applications, and don't think that Lambda is an exception. Remote code executions are the case for Lambda. Timing attacks, Node.js timing attacks are very often case for Lambdas. And also think about the tools which will fit to your purpose. For example, Node.js Scan, open source, very cool and very good for Node.js application. Bandit for example, Python application or Python framework. If you are looking for open source, which will help you to do pretty good scanning for free, look for StemGrep. StemGrep is something that's for free, huge support of languages, and it's pretty fast. If you want to go with enterprise grade, go with Checkmarx or Fortify. Serverless top 10 is actually the thing. If you will go to OWASP pages, you will find lots of interesting informations, including the presentation from 2017 or 18. Now, this like two major resources. If you will go to the PDF will basically show you the mapping on OWASP top 10 to serverless functions. If you will look at that closely, you will see that cross-site scripting is still a thing for serverless, injections too. So using component with known vulnerabilities is still a problem. If you will go through it, you will see lots of interesting informations about, for example, Boto tree problems, Lambda problems that can affect your application, which is based on serverless. And this is something what is right spot on to read, check, and practice. I think that was a lot for today, and see you next time.